An offshore oil platform can spend decades making money. Then the oil field reaches the end of its life. The wells are shut down. Production stops. The workers leave. But the platform doesn't go anywhere. The steel is still there. The foundations are still there. And someone still has to deal with it. Wellheads, pipework, cranes, rusted steel, heavy lift ship, scrapyard, underwater structure. And in the UK, the estimated cost of decommissioning the remaining offshore oil and gas infrastructure is about £41 billion in 2021 prices. The estimated impact on the UK exchequer is another £11.7 billion in present value terms. So where do these enormous machines actually go when the oil is gone? The answer isn't one place. Some are dismantled, some are recycled. Some components can remain offshore under strict regulations. And in the United States, some former platforms have been turned into artificial reefs. But getting from oil producer to scrap reef or something in between can be one of the most complicated parts of the platform's entire life. Before we go any further, there's a terminology problem. People use oil rig to describe almost anything offshore. Technically, that's not quite right. A mobile drilling rig is different from a fixed production platform. A floating production facility is different again. And regulators often use the broader term offshore installation. So for this video, we'll use oil rig as shorthand. But the real story is about what happens to these offshore installations when they reach the end of their productive lives. And that's when their economics completely change. While the platform is operating, the question is, how much oil can it produce? At the end, the question becomes, how do we safely take it apart? That's a very different business. Look at an offshore platform, and it's easy to think of it as one giant machine. It isn't. It's an entire industrial facility. There are production systems, generators, pipes, living quarters, cranes, electrical equipment, and below the waterline, there are wells, foundations, and subsea infrastructure. Everything was designed to survive years of wind, waves, saltwater, storms, heavy machinery, and constant industrial use. Now try to reverse the process. Before the structure can be removed, the wells have to be permanently secured. Equipment has to be taken out. Materials have to be handled safely. The structure may have to be divided into sections. And those sections have to be transported somewhere that can process them. So decommissioning isn't one job, it's an entire chain of operations. And every step costs money. But where do you actually take something this big? One destination is an industrial port. Cromarty Firth in Scotland is one example of a place with a long history of offshore and marine activity. From the air, it looks peaceful. Green hills, calm water. Then you see the steel. For a retired offshore installation, a place like this can become a kind of waiting room. It may be waiting for dismantling, refurbishment, reuse, recycling, or another decision about its final fate. And this isn't some theoretical process. Since the OSPAR dumping ban came into force in 1999, 170 offshore installations have been brought ashore for disposal. But bringing them ashore is only the beginning, because one platform can contain thousands of tons of material. And before the industry figured out how to deal with these structures, it faced a much bigger question. What if you simply left them in the ocean? In 1995, Shell had exactly that problem. The Brent Spar was a huge floating storage and loading facility in the North Sea. It was no longer needed. Shell's proposed solution was to tow it into the North Atlantic and sink it in deep water. On paper, the logic was simple. Take an obsolete structure, move it away from the shipping lanes, put it on the seabed. Problem solved. Then Greenpeace got involved. On April 30th, 1995, Greenpeace activists occupied the Brent Spar. Suddenly, images of people standing on a giant offshore structure were appearing across television screens. And the story changed. It was no longer simply, what do we do with an obsolete platform? It became, should the ocean be used as a dumping ground for industrial infrastructure? Protests spread. Shell faced boycotts in parts of Europe. Political pressure increased. But Shell didn't immediately abandon the plan. On June 10th, Shell began towing the Brent Spar toward its planned disposal area. The structure was actually on its way, and the controversy kept growing. Eventually, Shell changed course. The Brent Spar was brought to Norway, where it was cleaned and later reused as part of a harbor structure. The episode became one of the defining environmental controversies surrounding offshore oil in the 1990s. And it helped shape the debate over what should happen to disused offshore installations. In 1998, OSPAR adopted Decision 98/3 on the disposal of disused offshore installations. The basic rule was straightforward. Disused offshore installations in the OSPAR maritime area could not simply be dumped or left wholly or partly in place. There are exceptions, but they're limited. Certain categories, including some steel installations weighing more than 10,000 tons in air and certain gravity-based concrete installations, can be considered for derogation following assessment and consultation. So the rule isn't, every platform must always be completely removed. It's closer to, removal is the normal outcome, and leaving certain structures or parts in place requires a specific regulatory case. That changed the question. The industry could no longer simply ask, how do we get rid of this? It had to ask, what is the safest and most environmentally acceptable way to end its life? And that brings us to the money. £41 billion. The North Sea Transition Authority estimated that the total industry cost from 2023 onward of decommissioning UK upstream oil and gas infrastructure would be around £41 billion in 2021 prices. That's not one platform. It's the wider remaining decommissioning liability across the UK offshore industry. And here's where things get interesting. Because when people hear £41 billion, they may imagine the government writing a £41 billion check. That's not what the number means. The companies responsible for the infrastructure carry the decommissioning costs. But those costs affect the tax system. HMRC estimates that the exchequer impact could be around £11.7 billion in present value terms. That includes about £5.8 billion in tax repayments associated with decommissioning expenditure, and another £5.9 billion in foregone offshore corporation tax revenue, because decommissioning costs reduce company profits and therefore tax receipts. So the decommissioning bill isn't simply a private company problem, it has consequences for the public finances too. And that creates one of the strangest features of the oil business. The revenue can arrive while the field is producing. The cleanup bill can arrive long after. Now imagine the field changes hands. An operator sells an asset. A company restructures. Production ends. The platform is still sitting there. The obligation doesn't disappear with the oil. That's why decommissioning is built into the regulatory and financial framework around offshore production. Companies have to plan for the end of the asset's life, and the financial consequences can extend far beyond the day production stops. Production ends, liability remains. Which means an offshore oil field has something like an afterlife, and that afterlife can be expensive. But money isn't the only problem. There's still the physical structure, thousands of tons of steel, concrete, pipework, equipment, and potentially hazardous materials. What happens to all of it? You might imagine the process is simple. Take the platform apart, put the steel on trucks, send it to a recycling plant. In reality, it's far more complicated. You're dealing with enormous structural sections, heavy lifting, confined spaces, residual hydrocarbons, specialized vessels, transportation, waste regulations, and equipment that may have spent decades exposed to seawater and industrial processes. Some parts can be reused. Much of the steel can potentially be recycled. Other materials require different treatment, and sometimes the structure can't simply be lifted out as one piece. The topsides and substructure may need to be handled separately. So the platform's final journey can look less like move the rig and more like disassemble an industrial city and move it piece by piece. But there's one more possibility. What if the structure has already become something useful? Underwater, an offshore structure can look completely different. Steel becomes hard habitat. Marine organisms colonize the surfaces. Small organisms attract fish, and the structure can become part of the local marine environment. In the Gulf of Mexico, hundreds of former offshore structures have been converted into artificial reefs through the Rigs to Reefs program. At first glance, it sounds like the perfect ending. An oil platform stops producing oil and becomes habitat. But there's a catch. Seeing fish around an artificial structure doesn't automatically prove that the structure has increased the overall fish population. It may create new habitat. It may concentrate animals that were already in the area, and its effects can vary depending on the location, design, and species involved. NOAA research says artificial structures can create habitat and concentrate marine life, but also notes that their effects on actual biological production, species dispersal, and other ecological outcomes are more complicated. So the real question isn't, do fish live around old oil platforms? They clearly can. The harder question is leaving this structure here better for the ecosystem than removing it? And that answer isn't universal. Cromarty Firth, heavy lift ship, dismantling yard, steel being cut, recycling, underwater platform, fish. So where do billion-dollar oil rigs go to die? Not to one place. Some come into industrial ports. Some are dismantled. Some materials are recycled. Some require specialized disposal. Certain structures or parts can remain offshore under tightly controlled regulatory exceptions. And in the United States, some eligible structures can become artificial reefs. There isn't one giant graveyard. There is a chain of possible endings. And choosing between them depends on engineering, economics, environmental risk, and regulation. For decades, an offshore platform has one job: extract value from the ocean. Oil comes out, money goes in, workers maintain it, ships supply it, and the entire structure exists for one purpose. Then the oil field declines, production stops, and suddenly the same platform has a completely different identity. It's no longer an asset producing revenue. It's an asset that needs an ending. Maybe that ending is a dismantling yard. Maybe it's recycled steel. Maybe certain parts remain offshore under a carefully assessed exception. Maybe, in the right circumstances, it becomes artificial habitat. But none of those outcomes is automatic. Every platform eventually reaches the same question: what should happen to it when the oil is gone? And that's the strange economics of offshore infrastructure. The oil field has an expiration date. The infrastructure doesn't. Where billion-dollar oil rigs go to die, they don't all go to the same place. They just enter a very expensive afterlife.